You know, when you sent in your request for a deep dive on these Bennu findings, I immediately thought, wow, this is going to be fascinating. It's not every day we get to look at, the building blocks of life, especially ones delivered from space.
It's remarkable, really, this mission to Bennu, bringing back these pristine samples. It's like a time capsule from the early solar system.
Yeah, so let's set the scene. The OSIRIS-REx spacecraft went over 320 million kilometers to this asteroid and back to collect a sample that weighs less than a bag of chips. Why go through all that for just a tiny amount of dust?
Well, unlike meteorites, which get contaminated, when they crash through the atmosphere, these Bennu samples are pure. They give us a glimpse into the solar system's history, untouched and untainted. What they found has researchers really excited.
Okay, well, intrigue me. When I first saw the headlines about table salt on an asteroid, I have to admit I laughed a little. But now I'm starting to see it's more than a fun fact.
Absolutely. The presence of sodium chloride, other salts, and even evidence of liquid water in the past is really important. These elements are key for creating the kind of environment where organic molecules can form, the foundation of life.
So it's like having all the ingredients, but you still need the right tools to bake a cake.
That's a great analogy. If we think of atoms like basic Lego bricks, you can combine them to make simple molecules. But to get life, you need those complex carbon-containing organic molecules. Think of them like the specialized Lego pieces. The gears, hinges, things that let you build something really complex.
And that's where things got interesting. They found 14 of the 20 amino acids essential for life on Earth, right there on Bennu. They even found all 5 bases that make up our DNA and RNA. That's like finding a partially built spaceship on another planet, right? Some tantalizing evidence.
Exactly. Amino acids are key because they form proteins, the workhorses of all living cells. They're like those specialized Lego pieces that let you build complex structures. You can't have a functional spaceship without the right parts, and you can't have life without proteins.
Then there's the ammonia, and apparently lots of it, I thought ammonia was like a cleaning product, not a building block of life.
It might seem surprising, but ammonia is vital for forming those amino acids. Finding it in such a high concentration on Bennu, much higher than samples from other asteroids, tells us a lot about how active the chemistry was back in the early solar system.
So how did all these ingredients get to Bennu in the first place? Some kind of cosmic delivery service?
There are a couple of possibilities, and they're both pretty mind-blowing. These building blocks might have formed in the outer solar system, where it's colder and ammonia ice is stable, or, and this is where it gets exciting,
All right, lay it on me.
they might have come from a completely different solar system and traveled through interstellar space to reach Bennu ingredients for life, hopping between star systems.
Hold on, now that's a big jump. Interstellar ingredients for life. How could something like that happen?
It all comes down to how stars and planets form. When a star goes supernova, it throws out huge amounts of material. Some of that can clump together, forming new stars and planets. But some of those building blocks, like those we find on Bennu, can get pulled in by the gravity of other systems, like a cosmic game of pinball with these ingredients bouncing around the galaxy.
Wow, incredible. It really makes you think about how connected everything in the universe might be. Okay, so we've got these building blocks, potentially from other solar systems hanging out on Bennu. But are we saying we've proved the Panspermia Hypothesis that life on Earth came from space?
It's tempting to say that, but we need to be careful. Finding the ingredients is one thing, but it's not the same as finding the finished cake. We've got the raw materials and a possible location where they might have mixed, but we still haven't found proof that life started on Bennu and then came to Earth.
So the mystery continues. What else did they find on Bennu that could help solve this puzzle?
Well, besides all the usual suspects, they found 19 non-protein amino acids, the type that aren't used by any life forms on Earth.
Wait, what amino acids that don't exist in Earth's biology? That's like finding a Lego piece that doesn't fit with any set you've ever seen.
It's not just that they don't fit with our current sets. It suggests there might be entirely different sets out there. It challenges how we think about life itself and suggests that the chemistry of life could be much more diverse than we thought.
So instead of just searching for life as we know it, we need to be open to the possibility of life as we don't know it, life that might be based on a completely different set of building blocks.
Exactly. These non-protein amino acids ask some pretty big questions about the potential for life beyond Earth. It opens up the possibility of organisms with proteins that work in ways we can't even imagine, with structures and abilities unlike anything we've ever encountered.
That's fascinating and a bit intimidating at the same time.
Absolutely, it shows us how much we still don't know about the universe and what's possible. But this is just the beginning. We've only analyzed a small part of the Bennu samples, most of it's being saved for future research.
It's like having a treasure chest full of clues, and we've only just started to look inside. What secrets do you think are still hidden in those samples?
Well, as technology gets better, we'll be able to study those samples with even more detail, potentially finding new compounds and even more information about what the early solar system was like.
So it's not just about what we know now, it's about what we might learn in the future. this tiny piece of asteroid might have clues that rewrite how we understand life itself. But let's bring it back down to Earth. What do these findings mean for the search for life beyond our planet?
They have huge implications. If these building blocks are as common as Bennu suggests, the potential for life might be much more common in our solar system and beyond than we ever thought.
Okay, that's a perfect segue into the next part of our deep dive. We've talked about the incredible findings from Bennu, but what about those other interesting places in our cosmic neighborhood? Where should we be looking next?
That's a great question. There are a few top candidates right here in our solar system that we'll discuss in Part 2 places, like Europa Enceladus, and even Ceres are full of possibilities.
Welcome back, everyone. I don't know about you, but I'm still thinking about those Bennu discoveries. To think those tiny pieces of dust might tell us about where life came from, it's amazing.
It really changes how you look at things, right? For so long, we've thought of Earth as this special place where life started. But what if the ingredients are all over the universe, just waiting for the right conditions?
Exactly. And speaking of conditions, in part one, we talked about some other cool places in our solar system that might be able to support life. Let's talk about those, starting with Europa, a place that scientists and sci-fi fans love.
Europa, Jupiter's icy moon. It's a mysterious world, but one with a lot of potential. Imagine a moon covered in ice, but under that ice, maybe with more water than all of Earth's oceans combined.
An ocean under miles of ice. That sounds like science fiction. But what makes scientists think this hidden ocean could have life?
It's not just the water, it's what we think might be happening under the ice. The gravity of Jupiter pulls on Europa, creating friction and heat that keeps the ocean liquid. And where there's liquid water and heat, there could be hydrothermal vents like those on Earth's ocean floor.
Okay, wait a minute. Hydrothermal vents, those are like underwater geysers, right? What's so special about them?
On Earth, hydrothermal vents are full of life, even in the deepest, darkest parts of the ocean, where sunlight can't reach. They release chemicals from inside the Earth that provide energy for unique ecosystems that don't need sunlight at all.
So if Europa has similar vents, could they be supporting life forms that are living in those dark depths, totally different from anything on Earth?
It's a very interesting possibility, and there's more evidence. The Hubble Space Telescope has seen plumes of water vapor coming from Europa's surface. They probably come from that ocean under the ice.
Plumes of water vapor. It's like Europa is sending us a message saying, come and see what's down here.
Exactly, and that's what NASA's going to do with the Europa Clipper mission. It's a spacecraft that will orbit Jupiter and fly close to Europa many times, studying its icy surface, its interior, and those plumes.
So we might be able to see into that ocean without having to drill through miles of ice.
Maybe the Europa Clipper has instruments that can analyze what those plumes are made of, looking for signs of organic molecules, salts, and other things that might suggest life.
Okay, so Europa is definitely a place to watch. But what about other contenders? Didn't you mention Enceladus too?
Yes, Enceladus, a moon of Saturn. It's even more dramatic than Europa. Imagine geysers of water ice erupting from its south pole, shooting into space and creating a giant plume that makes up one of Saturn's rings.
Geysers shooting into space. Now that's something I'd like to see. But is it just water and ice? Or is there something more exciting under Enceladus' surface?
You got it. Another ocean under the surface. And just like Europa, Enceladus' ocean is probably heated by gravity, creating the potential for hydrothermal vents.
So we've got two icy moons, both with hidden oceans and maybe hydrothermal vents. It seems like the ingredients for life are pretty common out there.
It definitely makes things interesting. But what's really cool about Enceladus is that we've already sampled those plumes. The Cassini spacecraft flew right through them and analyzed what they were made of.
And what did Cassini find? Tell me the good stuff.
Cassini found complex organic molecules, salts, silica, and even tiny bits of rock. All signs that the ocean on Enceladus is touching its rocky core, creating the kind of chemical mixing that we think is necessary for life.
It's like Enceladus is giving us the ingredients and saying, here you go, take a look.
And we're looking closely. Scientists are already designing missions to search for life in Enceladus's plumes, maybe even bring samples back to Earth to study.
Okay, so Europa and Enceladus both have strong evidence of being habitable. Are there any other places in our solar system we should keep an eye on?
There's one more interesting candidate, but it's a bit different from the icy moons we've been talking about, Ceres.
Ceres, isn't that a dwarf planet in the asteroid belt? What makes it a possible place for life?
Ceres is a bit of a mystery. It's much smaller than Europa or Enceladus, but it's also much closer in the asteroid belt between Mars and Jupiter. What's interesting about Ceres is that it seems to have a lot of water ice under its surface, probably mixed with salts and minerals.
So not a global ocean like Europa and Enceladus, but still a potential source of liquid water.
Right. And remember, water is key for life as we know it. Plus, Ceres has something else, organic molecules. The Dawn spacecraft orbited Ceres for a few years, and it found evidence of organic compounds on the surface. This suggests that Ceres might have been much warmer and wetter long ago.
So Ceres might have had the right stuff for life in the past, but what about now? Could there still be life on Ceres today?
That's a harder question. Ceres is much less active than Europa or Enceladus, and its surface is bombarded with radiation from the sun. But it's possible that life could have survived in those pockets of water ice under the surface, maybe dormant, waiting for better conditions.
It's amazing to think that these three places, Europa, Enceladus, and Ceres, all have the potential for life, each with its own unique condition and possibilities. It seems like our solar system is full of potential, even if that life is hidden or exists in ways we don't understand yet.
And that's what makes the search for life beyond Earth so fascinating. We're not just looking for familiar creatures or ecosystems, we're exploring what life could be, challenging our ideas and expanding our understanding of the universe.
It reminds us that we've only just begun to explore what's out there. Who knows what amazing discoveries are waiting for us? But before we get ahead of ourselves, let's talk about the ethical side of going to these distant worlds. Especially if they do have life, it's something we can't ignore. And it's something that needs to be carefully considered.
Absolutely. The ethical implications of finding life on other planets are huge. They raise a whole new set of questions that we'll need to deal with as we explore the universe.
All right, listeners, we've covered a lot in this part of our deep dive, from the icy moons of Jupiter and Saturn to the intriguing dwarf planet Ceres. We've looked at the evidence, the possibilities, and the challenges of searching for life beyond Earth. But there's one more important thing we need to talk about: the ethical side of exploring these alien worlds. That's where we'll pick up in part 3 of our deep dive. So stay with us as we explore the philosophical and ethical questions that will shape the future of astrobiology. So we've explored some amazing possibilities in this deep dive: the building blocks of life on Bennu, those hidden oceans on Europa and Enceladus. But as we search for life out there, we can't ignore the ethical questions.
Yeah, it's a really important part of astrobiology that often gets lost in all the excitement of discovery. We're talking about maybe finding life that's totally different from anything we know, and we need to be ready to handle that responsibly.
Okay, so let's talk about those ethical dilemmas. Let's say we find evidence of microbes on Mars or in the plumes of Enceladus. What are our obligations to that life?
That's a question a lot of people are debating right now. Some people say we have to protect any life we find out there to avoid contaminating it with Earth stuff or messing up its natural evolution. It's called planetary protection.
So it's like going into a pristine wilderness area. We have to be careful not to leave our footprints.
Exactly. Imagine if we accidentally brought Earth bacteria to Mars or Enceladus. We could really mess up a delicate ecosystem.
That makes me think, how do we even know if something is harmful to alien life? What we think of as toxic is based on life on Earth. What if just being there, even with good intentions, is disruptive?
That's a big challenge. We don't really know what life could be, like what it needs or what could hurt it. The precautionary principle says we should be really careful, minimize contact until we understand more.
Okay, so let's imagine we've been careful and we found something more complex than microbes. Maybe even intelligent life. Do we try to make contact?
That's the big question, isn't it? One that humans have been thinking about for a long time. There are good arguments on both sides. Some say we should reach out, share what we know, and learn from other civilizations. Others say it's too dangerous. Contact could lead to bad things, like exploitation, conflict, or even the destruction of one or both civilizations.
It's like a science fiction story, but it's a real concern. Just look at human history. First contact between different cultures on Earth has often led to really bad outcomes.
Exactly. We have to think about the consequences, for us and for any alien civilization. What if we're not ready for the changes? A discovery like that could bring changes to our culture, our technology, even our philosophy.
These aren't easy questions, and there are no easy answers. It seems like the ethical side of astrobiology is just as complicated as the science.
I agree, and these challenges will only get harder as our technology gets better. And we can explore more of the universe. We need to have these discussions now before we have to make decisions that could have big consequences.
So what do we do? How do we get ready for the possibility of finding life out there and do it in a way that's responsible and respectful?
It starts with talking, not just scientists, but everyone. We need to listen to different points of view: philosophers, ethicists, artists, theologians. We need to develop rules for planetary protection and ways to handle contact if it happens. And maybe most importantly, we need to be humble and responsible as we explore the universe.
It really makes you think we might not be alone. Our way of life might not be the only way. It challenges everything we think we know about our place in the universe and makes us ask some really big questions about what it means to be human.
And that's one of the best things about searching for life beyond Earth. It gives us a chance to reflect on ourselves, our values, and where we fit in.
It's been an amazing journey exploring the building blocks of life, the possibility of life on other planets, and the really important ethical questions that come with all of this. And you know what? What started with your curiosity about some dust from an asteroid has led us to a universe of possibilities.
That's what's so great about science and exploration. Every discovery leads to new questions, new ways of looking at things. and a deeper appreciation for how amazing and complex the universe is.
We might not have all the answers, but it's the search that makes it so exciting. Who knows what we'll find next? Maybe one day we'll find proof that we're not alone, and that will change everything we thought we knew about life and our place in the cosmos.
Thanks for joining us on this deep dive. We'll be back next week with another fascinating topic. So until then, keep looking up, keep asking questions, and keep exploring.